Hello everyone, welcome to SN Dev, and in today's video we'll be seeing how to build a RAG based chatbot using LangChain and ChromaDB. Okay, in one of our previous video we have built a RAG based chatbot with streamlit interface with our fast vector databases. Okay, this time we'll be using ChromaDB, and of course we'll be using Gemini AI as an our LLM, which is free totally. And this time we'll be seeing the LangChain components of languages. Okay, we'll be seeing the fundamentals of document processing, embeddings, how to build a LangChain, the whole prompt chain, then how to handle follow-up questions, all those things. Okay, so before I get into the code, let's see the how a RAG works. Okay, so here you could see in the first red dotted box, this is the phase of document processing. Here you can provide any PDFs or doc extended documents, and after that in this second red dotted box, in the first step, all those documents gets into chunks, like some as per paragraph, as per words, or as per sentences. It converts into some chunk. Then those chunks gets embedded through an embedding model, and it gets transformed into a vector. Okay, and in this vector each and every words means each and every chunk, so that same same kind of chunks or same kind of paragraph should be in a same vector. Okay, then those embedding vectors will be stored in a vector databases over here, and in this case we'll be using ChromaDB for it. Okay, now let's say as an user you are asking some query from the chatbot. Okay, so your asked prompt will again convert into an embedding vector, and those vector will get mapped into all the information embedded vector in the vector databases. Then okay, so after that maps you will get some chunks out of it, which will be important for your as per your query. Then the LLM will give some own context to create a proper structure output, and then you could see the output in your screen. Okay, so this is how the basic of RAG works. You can study, you can read any article or books about RAG. Okay, so let's get into it. So what we'll see about LangChain components and expression languages, like how we can, like how to use LangChain with any LLM API to handle those responses. Then we'll see the document processing, we'll see how to create embeddings, we'll see how to set up our vector database, how to build the RAG chain, and how to handle follow-up questions. Okay, so these are the fundamentals of RAG. So if you understand each and this thing, you can easily build any production ready chatbot using RAG. Okay, so let's start the code. Alright, so first we'll see the LangChain components and expression languages fundamentals. Okay, so before that we'll be installing couple of libraries. So we need to install LangChain Google Gen AI, LangChain Core, and LangChain Community, doc to text and PyPDF, LangChain ChromaDB, and sentence transformer. Okay, so let me connect my GPU first, and this is I'm doing in my Colab. Okay, and alright, so I'll run this cell and it will install these libraries. So just wait a second. Alright, so let it happen. So we have understood about what RAG is. So now we'll talk about this LangChain component and expression language. But before that, we need to add our Gemini API, and we need to add our Langsmith API so that we can trace our project. Okay, so first let add us. So come in here and I'll import OS, and then I'll simply add OS dot environ, and here I'll name it as Google API key. Okay, and here I need to paste my Gemini API key, and you can find it from Google Developer Studio. I'll copy this, and don't need to copy my API key because I'll be deleting this. Wait, it's still installing. Okay, so after that we need to add our LangChain API. Okay, so for that, OS environ, and here I'll write LangChain tracing v2. Okay, I'll keep it as true. And if you want to know more about LangChain, just go through the LangChain documentation. You would get all over there. And then we need to add our LangChain API key. So LangChain API key. Here I need to give the API. I'll have this over here. So I'll just copy this and I'll paste it over here. And after that, I'll be needing os.environ, and this time I'll be needing LangChain project, because here each and every LangChain would be under a project. Okay, and this one is under my, you can see this RAG chatbot name. This RAG chatbot. Okay, so it's been installed properly. Now I'll run this cell, then I'll run this cell. Okay, done. Now we need to trace our API. So for that we need to we'll be seeing these 5 LangChain component and express languages fundamentals. So first is how to use LLM using LangChain, right? So for that I need to simply import this thing, LangChain Google Gen AI. From there I'll be import chat Google generative AI. Okay, then in LLM I'll take a variable as LLM. I'll call my chat Google generative AI, and I need to pass the model name. And as we are using the free version, so my model name would be Gemini -1.5- Flash, because this is the only the free version. Okay, then I'll create another variable where I'll store my response of my Gemini LLM. Here I'll simply use LLM, and the function that we'll be using to get our LLM response is invoke. So we'll invoke, and here I need to pass a simple, what is it, a prompt. So let's say I'll be saying key, like the basic one, let's say tell me a simple joke about, let's say, coding. Okay, after that I'll simply print the response. Simple. Now let's run this. Here you could see we have an AI message says, why do programmers prefer dark mode? Because light actors bug, all this thing. And it is also giving us some metadata, some others like this usage metadata, this safety rating, some other things as well. Now we need to trace each and every response of it now. So I'll come to my LangChain here, and here you could see, like, this is what I have done recently, like 0.63 latency. You can see if I just click on this, you could see that the human prompt was telling me a joke. Not this one, this one I tried earlier, this one, right? Okay, so this was my prompt, right? Tell me a simple joke about coding, and the AI output was, why do programmers prefer dark mode? Because of this. Okay, so it's giving you all the some inside data of it. So it's helpful when you are building some any big project. Okay, all right. So now our first thing is done, that how to use large language model. But here you could see that we have AI message, we have lots of other data as well that we don't require. So for that we have this output parser, it gives us a bit of cleaner output. So for that I need to import this thing from LangChain core. I'll be import this output parsers. Okay, from here I need to import str output parsers, like string output parser. Okay, so I need a variable output, let's say parser. I'll call my function string output parser. After that I simply need to invoke this. So output parser dot invoke my LLM response. So the response would be much more cleaner. So let me run this. Okay, so you could see here I only got this AI message. Why do programs favor dark mode? All this kind of thing. Okay, now we have structure output. Okay, so before giving a structure output, one of the main aspect of LangChain is that we can use a chain response. Like we can create chain, right? So let me show you how to create a chain first. So we have these two things. We have invoke our LLM into our response, and we have converted the response into a proper output parser. So if I need to create a chain, so let's say I'm taking a variable as chain here, and to create a chain we need to do it like that: LLM, this sign, and our output parser variable. Okay, then I simply need to chain dot invoke, and I need to pass my thing. So tell me a story, a bit different. So let me run this. Okay, so it has given me a story. Let's come here. Get it? Here you could see we have this one, right? All here it has given me some big story. Okay, so this is how you can create a chain of response. All right, so now our third step is to get a structured output from an LLM response, which generally we use Pydantic AI because it gives us those base models so that we can create a proper class, so that we can extract some field from the response. So for that I need to get this library first. So from typing I'll be importing list. Okay, and then from Pydantic I need to import my base model, and this called field, not this one. Okay, then I need to create a class. Let's say I'm naming it as review DSA. Okay, here I need to pass the base model. So base model colon, my class is ready. So before that I need to have a prompt that I'll be providing to my LLM, right? So for that, let's say prompt text. All right, here let me paste it. So I have it over here, so let me paste it. So this is the prompt that I have, that it is about dynamic programming X and some DSA topic. Okay, so after I have this prompt text, I'll be creating one variable as, let's say, structured LLM, and here LLM dot with structured output, and I need to pass my class within this. So review DSA. Okay, and we haven't built the class, but we'll be creating that later. So after that, in an variable, let's say output, I'll call this structured LLM and I'll invoke it, and I'll invoke my prompt text into it. Okay, prompt text. Then I'll simply print the output, and then I'll print some other field that I'll be creating later. So output. So let's build the class first. Okay, so to build the class, from this topic we need to extract some part, right? So what are the part that we can extract from this? We can extract that what the topic of this prompt, and what the rating that you could say that overall I would rate it 4.5 out of 5. So we can extract the rating. We can extract the pros of dynamic programming and cons of dynamic programming and the summary of it, right? So let's write those fields one by one. So first would be topic str, because it will be a string. Then I need to use my field. Here I need to pass the description. Here I need to provide that name of the DSA topic. Okay, then let's say I'm writing the summary in it. So summary str, again field, into the description what will be writing that write me the brief summary of the review. Okay, and you can also get the number, as you can see 4.5 out of 5. So it's a float. So for that, let's say rating dot it's a float, so I'll be writing this float, and then again simply field, then description I would write overall rating out of 5. Okay, and as we have imported list, so further we need to create something. So let's say let me import some pros of it. So pros, here I'll be creating list str, then simply field, I'll write in this description and list of positive aspects. Okay, so it's done. So from this response we would need this field, and after that we'll be providing this class into our structure output. Then we'll be providing our prompt text. So let me run this. And okay, so we are printing our output, so like our total output, but if you want to print some individual fields, so we can also do that. So let's say output dot pros. Okay, so now let me run this. Here you could see that the topic is dynamic programming, summary is this, but toughest thing, all this thing, rating is 4.5, pros is this, and all this kind of thing. And individually the output of output.pros would be optimizes recursive solution and all those kind of thing. So here you can get some structure output from the response as per your wish. Okay, now we have done with our prompt templates. Now we are done with our structure output. Now we need to talk about prompt templates. So prompt templates, this is where you can create some like dynamic prompts. Okay, and this LangChain component, this makes it easier to give some dynamic prompt about some topic. So for that I need to import from LangChain .core .prompts. I'll import chat prompt template. This will be prompts, so it's not prompts. Okay, and so in our prompt variable I'll simply call this chat whatever this prompt template is. Then here dot from template. Here I'll simply pass a prompt. Let's say tell me a joke about, as the in our previous one we have written that tell me a joke about coding. Okay, so this time I am keeping that space like this topic. Okay, and later in prompt dot invoke, what we're doing, I'll be simply right key this topic, but this will be under quotation. So this topic should be about, let's say what should I write, let's say sports. Okay, so let me run this. All right, so this is, I got, right, tell me a joke about sports. So I got my dynamic prompts over here. Okay, so now again let us create a chain with it. So chain prompt LLM output parser. Now for the result I'll simply invoke topic was sports, right? So sports, and simply I'll print the result. So let me run this. All right, so why don't scientists trust atoms? Because they make up everything. It's not about sports, right? Tell me a joke about sports. Okay, so let me change this topic a bit. So let me change this topic. So let's say coding. Alright, so why do programmers prefer dark mode? Because light attracts bugs. So it's working, yeah, of course. Alright, so our last was LLM messages. Just to see how it works. It's simply like, and these messages contains two main type of messages. One is this system messages and one is human messages. And human message is like that human given prompt, and system messages, it's something to train the model that okay, behave like this, or you are like this, so behave like this kind of statements, messages. Okay, so for that let us write how it works. So LangChain .core .messages, and I'll import, as I said earlier, we need human message and we need system message. Okay, now we need to define those messages first. So messages would be in a string here. Wait, yeah, I need to provide this. So system message, I need to provide the content for system message. Here let's say you are a helpful coding assistant, and human message would be tell me a joke about debugging in code. Okay, it's done. Now what are we doing? To store this in response, I'll be writing response LLM dot invoke. Wait, it will be dot invoke. I'll pass the messages, and after that simply I'll print my response. So let me run this. Oh, wait a minute. Okay, it's been comma. Okay. Print response LLM dot invoke messages. So then I'm printing it. Name response is not defined. Response, of course. Response. Okay, so content. So the content is why do programmers prefer dark mode? Because light attracts bugs. Okay, so this is how it works. And you can also create a chain within it. So let's say if I use a template over here, not like this, let's say a template and chat prompt template. Here I'm giving my system messages. So let's say system this one and a helpful assistant, and for the human prompt, if I provide that tell me a joke, so it will give me. So then after it I need to create a chain for it. In chain I'll simply write my template and I need to provide my LLM. I'm not taking any output parser right now. So chain dot invoke, I need to invoke the topic first. So so chain dot invoke. So tell me a joke. I didn't write any content, so tell me a joke about, let's say, which one that I need to provide. So using prompt, let's say here topic should be let's say simply take as coding as of now. Then at last simply print. So I need to store this in somewhere. So result, so print result. Okay, so yeah, whatever dark mode it is giving me, it's all right. So we have seen all those LangChain components and expression languages. Okay, so now we'll talk about this document processing and all other RAG fundamentals. Okay, so now our first fundamentals for RAG chatbot would be to process our documents, right? So for that, let me first run it. And I didn't show you guys that all this output is stored over here. You could see that runnable sequences, chat Google generative AI, chat prompt template, HT output parser, everything has been staged over here. Okay, all right. So now we have document processing. So for that we need to upload our document, right? So for that I'll be creating one folder over here as docs, and inside of this docs I'll upload one file, one documents. So I'm uploading this one. Okay, so now over here, so first let me install this pip install docx2 txt. Okay, so it's been installed properly. So now let's see if it's uploaded or not. It's been uploaded. Great. Now we need to import a couple of libraries, right? So first from LangChain community to import not only community, also community dot documents loaders, because we need to upload documents. We need to import py pdf loader, this one, and we need to import docx2 txt loader. Okay, all right. Now from LangChain text splitters, we need to import our recursive character text splitter, because we'll be doing loading and splitting together. And after this, from typing, we need to import our list, and also from LangChain core documents, we need to import document. Okay, and as file will be from otherwhere, so we need to import OS. Okay, so to figure out how we'll be splitting our text, we need to define this text splitter. So text splitter, let's call our recursive text splitter, character text splitter, and we need to provide some parameter to it. So chunk, let's say size, I'm keeping it as 1000. Chunk overlap, I'm keeping it as 200, and length function, I'm defining it as len. Okay, now I need to upload it. So docx loader, docx to txt loader, I'll be simply need to provide the path. So come here, and I'll simply copy this path and I'll paste it over here. See, content docs, all this thing. Okay, now to store this, I'll be storing it into this documents variable. So documents docx loader, and I'll be simply calling this load function. Okay, it will be x, not x. Okay, now to split it, for our splits variable, I'll name it as text splitter dot split documents. I need to provide my documents over here. Okay, again to provide my documents. Then to check if it's been uploaded or not, I need to provide a message. So split it with, say, len splits. So split it with this much chunks, and the length of the documents would be, to just simply pass the documents. So the length of document is this. Len, I think it's like this. Len. Okay, it won't be curly brace, it will be first bracket. All right, so now let us run this. Here, over here, you could see that's splitted with 10 chunks, and the document length is 1 because we have one document, so it's been splitted with 10 chunks. So let us import another document over here. So not now, because we have already only given path one document, so we'll be doing the latter. So all right, and let us see some aspect of it. So let's say documents 0. Okay, wait a minute, documents 0, what should be this? So it has given me the first chunk of this document. Okay, all this, and then again, if I check the first part of the splits 0, giving me this. Okay, so this is the whole document that I provided, and after the splitting and so this was the first chunk. Here I have the my summary of my CV. Okay, and some of my link, all those things. Okay, so the document processing is done. Now in the next part we'll be seeing how to create embeddings. Okay, all right, so now let us create a function so that we can handle PDF and documents together. Okay, so I have uploaded two more documents. So I have uploaded this one document and one this PDF. Okay, so we need to write a function for this. So let's say def load documents and folder path, and I'll be providing the URL. So string with as a list formation document. Okay, sorry, it would be document. Right. Now let me create an empty array for the documents. Now for file name in os dot list directory, be providing the folder path, then file path will be os dot path dot join folder path and file name. Okay, now if file name dot ends with let's say first dot pdf will be, as in the loader, will be calling our py-pdf loader. Okay, and here we'll be providing our file path. Okay, now elif is file name dot ends with, let's say docx, right? So it would be in loader I need to call docx to txt loader. I need to pass my file path into it, and then if I provide anything out of this extension like CSV file or anything else, then for handling the error, let's say unsupported file type, and let describe the file name, right, and then continue. Okay, all right, and document dot extend. After that I need to loader dot, this is how I'll be loading the documents. Okay, then simply return the documents. Okay, now to provide the folder path we need to give it. So folder path, how would I give it? So for that, come to this doc, right click, copy this path and paste it over here. Okay, and in documents we'll load documents, provide this folder path. Okay, and then print f string loaded to see how many documents we have loaded. So loaded documents from folder. Okay, then we need to split it. So splits will call our text splitter dot split our documents. We need to provide our documents, and it at last will simply print to check if it's been splitted or not. Splitted documents into, let's say, length of splits chunks. Okay, so let me run this. Okay, there is some error. Okay, it's a htr object has no attribute as file name. All right, so let me check folder path. htr document have no attribute. Okay, it would be comma, not doc. All right, so you could see we have loaded 5 from folder, splitted documents into 30 chunk. All right, as we have done 2 earlier, so it's counting all as per before and just giving me the loaded 5 from folder and splitted document into 30 chunk. And now if I documents 1, may this one portfolios, and let's say I'm showing it key, show me splits 4. Sorry, it would be splits 4. So it's giving me this one. Okay, all right, now in this time we'll be creating the embeddings. So to embeddings we have 2 types of way so that we can embed. One is to use Google generative AI embedding model, and second is to use sentence transformer. So first we'll be using with Google generative AI embedding. Okay, so we have installed all those. So from LangChain Google Gen AI, I'll simply import Google generative AI embeddings. Okay, so in embeddings I'll be calling this function. So Google generative AI embedding. Here I need to provide the model name, and this model name, take it very carefully because it is the free one. So embedding -001, this is the only embedding models. Okay, all right, so now after this we'll be simply use documents. In document embedding we'll call this embeddings dot embed documents. We'll pass our splits dot page content. It will be embedding page content for split in splits. Okay, then to check I'll say print if string created embedding for length of documents embedding documents chunks. So this is how I'll be creating embedding from a document chunks. Okay, again some error, list object has no attribute as page content. So splits dot page content, so it will be split, not split. So created embedding for 30 document chunks. So I have this 30 document chunks, you could see over here. So we have created embedding for these documents. Okay, all right, so now our task is to set up our vector store. Okay, so in this video we'll be using ChromaDB as our vector store. So let us write the code for it. So as we have installed our ChromaDB, LangChain ChromaDB. Okay, so from, let's say LangChain Chroma, will import what? Chroma. Okay, All right, now embedding function, Google Generative AI embedding. The model name, as I've said earlier, model slash embedding -001. Okay, after this I need to create one collection name. So collection name would be my collection. Then in the vector store I need to use chroma dot from documents. So from documents, then I need to pass some parameter over here. So first would be the collection name. This collection name is my collection name. Okay, then it will be documents would be splits, and embedding would be embedding function, and last parameter would be this persist directory. I'll be naming it as slash ChromaDB. Okay, and then I'll simply, for the checking purpose, simply write vector store created and persisted to ChromaDB. Okay, all right, now let me run this, and it have created that vector store created and persisted to ChromaDB. Let's wait a bit, it will come over here. You can see ChromaDB is came. So here we have our vector, our embedded vector. Okay, all right, so now let me insert over here. So now, as we have seen in the architecture, that after the vector store we need to like when user will give a query, as per the query it will perform a similarity search, so that we get the similarity chunks or embed from our vector database, so that our LLM can generate the response as per that embedded vectors. So for that, after I've created my database, let me check. Let's say query. I'm gonna give you a query that as per my PDF. So my PDF is consist of my resume, right? And this and my resume holds a summary section at first. So what is the resume summary? Okay, then search results, vector store dot this similarity search. Here I'll provide my query, and I'll provide this parameter to, okay, and print using an if string. So why I'm saying K2? Because it will give me the top 2 more relevant search. Top 2 most relevant search query. Okay, so after that, just simply need to pass my query over here. Done. Okay, so top 2 most relevant search for the query, and then for I result in enumerate, provide my search result over here. my SEARCH, my search results, and 1. Then I'll print that result of I, and I also need to print that from which source it's been generated. So result dot metadata source, and it would be unknown. Okay, and after that, to print the content, so I'll print this content, and result would be result dot page content. That's it. Okay, and at the last I'll simply print it. Alright, so there's an error. So dict object, so it will be source comma unknown result dot metadata. I need to provide this get at work. Alright, so as you could see that what is the summary. So the top 2 most relevant search for the query, what is summary, it has given result 1 content summary. Like if I have to show my resume that I have provided over here, so let's say for this one, my CV has this summary section over here. Okay, so it's taking this summary from over here. So it's taking this summary from over here, and it's giving me that content summary, all this thing, education, and my result 2 again. So this one is from this supreme aml.docs, and this one is from this doc. So this 2 is taking from same one. Okay, all right, so we are done with this thing, and what more we are left with? We need to create a retriever. So we have created our vector store, we have performed our similarity search, and now we need to create a retriever, and this retriever will help for LLM to retrieve the proper information from our vector store. Okay, so to create this retriever, simply need to write this retriever would be vector store dot as I have to provide this as a retriever here, search here, it for this search cogs to provide that I need like I want the top most flavored chunk, right? So retriever underscore results would be this retriever dot invoke. So let's say who is the candidate. So who is the candidate whose CV we are seeing? It's just a basic prompt that I've given. Okay, so let's see if it can give me the proper answer or not. Then print retriever results. Okay, So see, document ID this one, content summary, enthusiastic, detail oriented, or active learning, all this kind of thing. So okay, so it will retrieve as per the information that, like, after taking the chunks from the vector store, it will retrieve the document from the top to most similar chunks. Okay, so okay, so in our next part we need to build the RAG chain. So let's build the RAG chain now. So for the RAG chain, as we have seen earlier, that we have used chat prompt template and we have used HT, like string output parser. So we'll be using all together to create a proper chain. Okay, so let's do this. So from LangChain core dot prompts will be import chat prompt template. Then from LangChain dot schema dot runnable will import runnable pass through. Okay, and for our output parser will be import from LangChain dot core output, it would be dot output parser will import HT output parser. Okay, I think there is an error. LangChain, it would be underscore dot output parsers from LangChain. All right, now we need to first provide the template, right? So template, okay, so over here I need to provide the template. So answer the question based only on the following context. Okay, then I need to provide some context. Then for the question, I'll be giving some question, then answer. Okay, all right, so I need to cut this. Okay, now what will be the prompt? The prompt for this, I'll be using chat prompt template and dot from template. I'll simply provide this template over here. Okay, and then as the definition, as I'll be using docs, so docs to string, I'll be simply providing my docs over here. Then I'll return dot join doc dot page content for doc in doc. So whatever the page content I have in the doc, I'll be retrieving those over here. So over here, and I don't need this here. Okay, now I need to create the RAG chain. So RAG chain here. Now I need to in the curly braces I'll be providing the context, and also I need to provide the retriever, then I need to provide my docx to steer for loading the document. Then for the question I'll be using runnable pass through. It is a function. And for the chain, choose the chain this, then chain LLM, then chain str output parser function. Okay, so my RAG chain is done. So this is how my RAG chain will work. So let me run this. All right, now let's see with giving the question. So the question would be, let's say, which college does the person studies? Cause in my CV I have that which college currently I am now, so it should give me the answer of which college I am studying. So question response would be RAG chain dot, sorry, it would be invoke, and I have to provide the question over here. Okay. Then simply in print in question it would be question. Okay, and I need to print the response as well. Response, sorry, be response. Okay, so let me run this. So which college does the person studies? It is MCQ instead of engineering. You could see MCQ is engineering. Okay, so it's working, of course. And so the last part that is over is to handle follow-up question, and in this we have two main parts: to create a history aware retriever and to using this history aware to build a RAG chain. Okay, all right, so now we need to figure out that how can we create a history aware retriever so that my model understood that what kind of conversation I'm having with it. Okay, so for it, again I need to, let's say, import LangChain code prompts. From there I'll import message placeholder, and from LangChain.chains I'll import create history aware retriever, this one. Okay, then again from LangChain.chains dot combine documents. We'll simply import create stuff documents chain. Okay, LangChain, it will be chains, LangChain.chains stuff documents chain. Okay, now I need to give my model a context that how it should behave and how it should process that history awareness. Okay, so context prompt. Okay, now I need to give it some context prompt. Okay, so let's say given a chat history and latest user question which might reference context in chat history. Formulate a standalone question which can be understood, okay, without the chat history, and do not answer the question. Just formulate if needed, otherwise as it is. So what is I wrote here that given a chat history and latest user question which might reference context in the chat history, mean like whatever chat I'm doing in the chat base, understand it and formulate a standalone question which can be understood without the chat history. Mean, let's say if I ask earlier that which college does the person study, so I'm asking this model to formulate a new question as per this question, like after which college does the person study, what kind of question I might ask. I am asking to formulate this kind of question to it, okay, and I'm asking to just to formulate the question, don't answer. So you could see just formulate it, like do not answer the question, just formulate, okay. Now context queue, context prompt I've given it here, so let me give it context question system prompt because I'm giving it to the system, and write me this context queue prompt, and over here let me call my chat prompt template, and I'll be using dot from message so that it can retrieve from the message, and over here I'll pass couple of system messages. So system would be my context queue system prompt, so context queue system prompt, and message placeholder to provide chat history, and again for the human prompt I'll be giving it the input, okay. Alright, now let me create the context chain, and here I'll call my context queue prompt, I'll call my LLM, I'll call my str string out parser, okay. After that I'll simply print this, print context chain dot, I'll invoke here, I'll have to pass those formats. So input I'm giving as what does his CGPA, okay, and I'm passing chat history blank. Chat history should be blank like this. I think it's okay. Alright, now let me run this. Okay, there is an error. Context queue prompt from message, context queue prompt, chat prompt template dot from, it will be messages, sorry, messages, now run with this. Okay, context chain. Alright, so as per this input, what does his CGPA? It has formulated its own question, what is his CGPA, to understand itself. Okay, now after that we need to create this using history aware RAG chain. So let me do this. So let us do this. So again, from LangChain dot chains, I'll import create retrieval chain, then history aware retriever, history aware retriever, be only history aware retriever. Here I need to pass this function totally, and here I'll pass this LLM and my retriever over here, and this context queue prompt. Okay, then question answer prompt would be chat prompt template I'll be using again. So in chat prompt template, from messages, again I need to provide those system messages, all those things. So I'll be just copying it from over here. I'll copy it, I'll paste it over here, system. So here I won't be passing this context queue system prompt, I'll be using my own given prompt. So you are a helpful, the spelling, you are a helpful assistant. Okay, use following context to answer the user's question. Okay, then again context would be context. Okay, then message placeholder, I need to provide, before chat history I need to provide variable name chat history and human input. Okay, then question answer dot chain, I'll simply create my create staff document chain, and over here I'll pass my LLM and my question answer prompt that I've defined earlier, and I'll, in my RAG chain, I'll use this create retrieval chain, and I'll pass my history aware retriever. So history aware retriever and my question answer chain. Okay, all right, So now let me run this. It is done. Now let us give it the messages. Okay, so over here what I'll be doing, I'll be simply, again, let me import from LangChain code.messages. I'll import human messages and system message. Sorry, not system message, because now I'll be using AI message. Then chat history, as of now I'll be storing it as a blank. Then for the question one would be when where was his college. So this would be my first question. Okay, and the answer of it would be stored in answer 1. I'll be call my RAG chain dot, I'll invoke it. So I'll invoke over here input, then question 1, then chat history. This would be chat history. Okay, and after that I also need to print the answer. Alright, now after getting the answer, I need to store this into my chat history. So chat history dot, I'll be simply extend it to my human message. So human message, I need to provide my question 1. So my question 1 over here, and for the AI message I simply need to pass answer 1. Okay, so after this I'll simply print key question 1 and let me print again my answer 1. Okay, yeah, so let me run this first. Alright, human message object has no attribute as AI message. Okay, so human message object has no attribute AI message. Okay, it will be common. Alright, so where was his college? The student attended MCG Institute of Engineering in Havana. So now in the next part we'll be using this chat history to get answer of another question, right? So let me just copy this whole thing, I paste it over here, and here I'll be naming it as question 2 answer 2, and let's say what was his CGPA in his college. Okay, answer 2 would be same question, but here I need to pass question 2, and chat history would be chat history, that will be answer. Human message, here I need to pass question 2, here also I need to pass question 2, this should be question 2 and answer 2. Now run with this. So yeah, the provided text gives a secondary CGPA of this and this, it does not provide overall CGPA. Okay, so what was his CGPA, and run like this. So what it takes doesn't. Okay, I has HGPA in my. So let me run this. So HGPA. So his most recent HGPA is this. His college and giving. Okay. So this is how you can answer some history of a reaction. Okay. So this was all some fundamentals of RAG build chatbot. We have handled follow-up questions. We have built LangChain. We have set up our vector store. We have set up our embeddings. We have uploaded documents. So all these things. And yeah, and in next video, will we build a proper production ready chatbot with a streamlit interface, so that we can build a proper RAG based interface chatbot with some ChromaDB. Okay, so yeah, thanks for watching. See you in the next video.